Hi, today I will be talking about fault tolerance and how to migrate service to multi-region in the cloud. Services and resources are located in an availability zone inside a region, like US East or US West. We can have multiple availability zones in a region. Sometimes a whole region can fail, causing a whole service to die. But if we have a fault tolerance setup with a multi-region approach, disaster can be avoided. I am currently working at Globant as a DevOps engineer. We are a digitally native company that helps organizations reinvent themselves and unleash their potential. We are the place where innovation, design, and engineering met scale. Since I started working in the cloud, I've noticed that even with high availability, there is a chance that a whole region fails and critical services that need 100% uptime are not available, generating massive loss to the clients. The process not only to modernize these services, but also migrate them to be multi-region can be quite taxing, but if done correctly, it will generate a peace of mind to stakeholders, clients, and end users. I will explain the difference between high availability versus fault tolerance, and then provide some pointers to go with multi-region in a complex service. So, first, what is high availability? High availability is the ability of a service to remain operational with minimal downtime in the event of disruption. Disruptions include hardware failure, networking problems, or security events like a DDoS attack. In a highly available system, the infrastructure services are spread across a cluster of instances. If one of these instances fails, the workloads running on it automatically move to other servers or instances. These clusters are normally set up across different availability zones, but all in the same region. The main advantages are the easier maintenance, even if the design is more complex, because the scalability that it provides, and almost no service disruption, with a load balancing solution that will automatically divert the traffic to a functioning cluster. This means that we will need to set up double the components to provide this balancing solution, which can raise the cost, even if we are spending to prevent disruption. There is also a chance of data loss if there is data being transferred while the change of authority happens. And finally, there is still a chance of disruption. There's like a percentage of disruption that can cause severe loss in some services. And we have seen a full service failure over a regional disaster. Then we have fault tolerance, where there's no interruption of service. So it's a design concept where the service will continue working normally after experiencing an unexpected failure or malfunctioning with zero service interruption. So in this seamless transition, when there's a failure, it is the problem. So but also not only with failures, but when there's a need to upgrade, to change or perform maintenance on the service or hardware. Now, regarding data loss, there was a problem in high availability. Here is, if well implemented, there shouldn't be none. Because we have set up redundancy and we don't have that crossover component between active and passive systems, and we'll write and receive all of the requests. Obviously, the design concept that will assure that the service will continue to work if a whole region fails has a more costly and complex setup, but sometimes we have to weigh those things and decide what is better for the situation. Now, so both designs reduce the risk of service disruption and downtime, but they do so in different ways. Additionally, the two models tend to differ in terms of cost. When we choose which one to adopt, we have to take into account the level of disruption, the infrastructure requirements, and management effort in the design, setup, and operational maintenance. As I've been working with some sensitive projects that needed zero downtime and no data loss, I had to implement multi-region, and I like to provide some insight on how to implement it using a multi-region in AWS. So First of all, that we have to make sure is that we have a good cross-account replication and on the security resources, and cross-region replication on the security resources too. Authorization, encryption, auditing, and observability need to be replicated, and the data logs should be stored in an S3 bucket with multi-region replication, as we can see in this graphic. Luckily, AWS IAM, that's the users roles groups provider for AWS, has multi-region availability automatically, has no configuration required on your part. Then we have the AWS Secret Manager that can store secrets with KMS encryption, which can be replicated over secondary regions to ensure they can be retrieved in the closest and available region. Some services like S3 buckets and Aurora databases have cross-region replication, which makes the encryption steps more agile. But for those applications that run multi-region, there's an option to set up KMS multi-region keys, which will make your life easier on the encryption operations. As stated before, you can save all the CloudTrail logs in a replicated S3 storage, but keep in mind that you can also enable Security Hub to send all the findings from both regions to a single navigation pane. Second, but not less important, is networking, because we have to analyze and be aware of the networking infrastructure we are going to need to set up a global network. To communicate between the regions, we can use VPC peering. These resources can communicate using private IP addresses and do not require an internet gateway, a VPN, or separate network appliances. And by the way, it's cheaper than other options using a private cloud. For on-premise communication, we have Transit Gateway. It's a networking transit hub that connects your VPCs and on-premises networks. This can be enhanced to expand the additional regions with Transit Gateway inter-region peering to create a globally distributed private network for your resources. And now we have Route 53. That's the DNS solution to route the users to those distributed internet applications, and offers a comprehensive failover solution that has minimal dependencies. Then we have CloudFront. It's a content delivery network, like for websites, which allow us to manage our content closer to the end users with edge locations, but it's also possible to set it up with an origin failover if the primary origin is unavailable or returns a specific HTTP response status code that indicates a failure. CloudFront will automatically switch to the secondary origin. And then for internet-facing apps, we can set up a global accelerator, which automatically switches with true static and ICAS IPs with one single entry point, as you can seamlessly add or remove origins and redirect traffic within seconds. It also allows us to have traffic ways to test deployments. I've used global accelerators, and it's really useful for devs, not cloud engineers, because you have only to switch the weights and traffic all the workload, and it's a really good solution. It also helps with live fixes to production when some scenarios require it. Now, next we have compute. Depending on your infrastructure, there are different things to consider. For example, if you use EC2 instances, they have their corresponding EBS volumes. They are stored in one availability zone. But we have Data Lifecycle Manager to automate the replication to those volumes to another region. And if we use AMAs, we have replication over regions with easy-to-image builder. So we don't need to do this manually. If our service or application is based on microservices, which is a really good idea, we can use Amazon Elastic Container Registry, which has private image replication, which can be cross-region or cross-account. I use third-party container registry tools that generates the code from my pipelines and deploy them into my AWS infrastructure in both regions at the same time. So that's another option. For data replication, this is also a complicated topic because we have heard about this. This is the CAP theorem that states that we can have the three. We can have consistency, availability, and partition tolerance at the same time, and we need to choose two only and decide which two we select depending on our needs. So when we go for multi-region, the one that's harder to achieve is consistency due to the long distance between the services. I have already mentioned that S3 has multi-region replication. That's the simple storage service or buckets, or that we usually call them. This replication is one-way or two-way continuous, and this replication can also be applied as subset of items inside the bucket. For non-relational databases like DynamoDB, it has a global structure, has multi-writer capabilities, will detect the changes and replicate them in other regions. For cache, we have Elastic Cache for Redis. It offers a global data store to create fully managed, fast, reliable, and secure cross-region replica for the Redis caches and databases. And for relational databases, such as Aurora, is the clustering is in one region, is designated as the writer, and then we have secondary regions that are designated as read copies or read replicas. While only one instance can process the writers, Aurora MySQL supports write forwarding. That's a feature that will forward write queries from a secondary region endpoint to the primary region to simplify the logic in application code. Logical replication, which utilizes a database engine. Built-in replication technology can be set up for Amazon RDS, for MariaDB, MySQL, Oracle, PostgreSQL, and Aurora database. This means that a cross-region read replica will receive and process changes from the writer in the primary region. This will make local reads faster and can reduce data loss and recovery times in the case of a disaster by being promoted to a standalone instance. This technology can also be used to replicate data to a resource outside an Amazon RDS, like an EC2 instance, an on-premise server, or even a data lake. Third but not last, we have application management. This means that bigger part, side of the service, but has to be taken into account. For example, DevOps. I think it's important to plan what CI/CD tools are we going to use in order to deploy all of this infrastructure. Whether it's AWS Code Pipeline, GitLab CI, or Jenkins, pipelines will need to be configured to assure this double deployment. But at the same time, deploying first to one region and then to the other while the primary is working isn't as complicated as it seems. Working with variable files for each region and environment is a really good idea. I mostly use Terraform, which is really solid and allow us to review before we apply changes to the infrastructure. But AWS has CloudFormation that's also really solid and allow us to create and delete stacks and update them across multiple regions and multiple accounts with one simple template, obviously providing the corresponding variables. Now, depending on the architecture of our service, If we use the coupled applications, we will need an event manager. We have Event Bridge. This will help us provide a notification service across regions. Event Bridge is serverless, and we can use cross-region routing to interconnect messages between the resources. If you rely on PubSub messaging like SNS, can work with multiple destinations. So you can send messages to a central SQS that process orders from a multi-region application. And finally, to maintain visibility and observability over an application deployed across multiple regions and accounts that can generate like a lot of resources, you can create a trusted advisor dashboard, an operation dashboard that has that can be done with System Manager Explorer. These operation dashboards offer a unified view of resources like EC2, CloudWatch, AWS config data, and you can combine the metadata with Amazon Athena to create a multi-region and multi-account inventory with a good view of all of the resources. So you have heard me talk about all of these resources, and while I don't want to sound like an AWS evangelist, I think it's important to know that these options exist. Each cloud has similar resources and alternatives to build a fault-tolerant multi-region service. It's hard, but it's possible, and the outcome of the peace of mind it brings when disaster happens is something to take into consideration when designing or updating a service or an application. It has brought me a lot of solutions and helped me, to provide better architecture for my projects. So, thank you for listening, and I hope this information allows you to reinvent and think for better architecture, for better solutions as me. Thank you.